Alright, so here we're naming what type of lines. So the first pair is intersecting lines, and they have one point in common, so they have one solution. The second pair of lines are lines that are right on top of each other. They're called coinciding lines. They have infinitely many solutions. All of the points on one line are on the other line. And then the last pair are parallel lines. There's no points in common, so there's no solution. Alright, to solve by graphing, we're going to graph each line and then figure out if they intersect. We'll name the point they have in common, and if they're parallel, we'd say no solution, and if they're coinciding, infinitely many. So we'll put a point at -2 on the y-axis for plotting that y-intercept. That B is your beginning point, and then we'll rise 1, run 2. And then we'll connect these to form our first line. Alright, and then for the second line, we see x. So x is the same as 1x. Slope of 1 we'll write as 1 over 1. When we're graphing, we want to think of slope as a fraction. And then we'll plot our beginning point, our B, at -3 on the y-axis. We'll go up 1 to the right 1. Then we'll connect these to form our line. So these intersect at the point 2, -1. So that's our solution. Alright, next we have a slope of -3 as a fraction, -3 over 1. Y-intercept's 1. So plot a point at 1 and then go down 3 to the right 1. You could also go up 3 to the left 1. And then we'll connect those. Next, our slope is -2 over 1. We don't see a number out there, so our y-intercept is 0. So plot a point at the origin, then go down 2 to the right 1. We can see where they intersect. So we have a point at 1, -2. That's our solution, the place where they intersect. Next one, we have a slope of -2 over 1, y-intercept of 3. Plot a point at 3, go down 2 to the right 1. Next we have a slope of -2 over 1, y-intercept of -1. So plot a point at -1, go down 2 to the right 1. Notice that these are lines that have the same slope, but they have different y-intercepts. So they never will intersect. So you can either write empty set or you can write the words no solution. There is no place where they intersect. Next we have a slope of negative 2 over 1, or sorry, negative 1 as a fraction, negative 1 over 1, y-intercept of 2. So plot a point at 2, then go down 1 to the right 1. For the second one, our slope is 1/2, y-intercept's negative 1. So plot a point at negative 1 on the y-axis, then go up 1 to the right 2. You can also go down 1 to the left 2. And we'll connect those. They intersect at the point 2, 0. Next one, our slope is 2 over 1, y-intercept's negative 1. Plot a point at negative 1, go up 2 to the right 1. Next one, our slope is negative 4 over 1, y-intercept's 1. Plot a point at 1. Then go down 4 to the right 1. Sorry about that, I intended it to be 4 over 1 for the slope, positive 4. Y-intercept of 1, so put a point at 1, go down 4 to the left 1, and you'll see where they intersect. So we have a solution at negative 1, negative 3. Number 9, slope's 1/2, y-intercept's 3. Put a point at 3, go up 1 to the right 2. You can also go down 1 to left 2. We'll connect those. And then for this one, you're going to find 2 on the x-axis and then draw that vertical line in. They intersect at the point negative 2, 2. So if you only see one variable, x equal to a number is always going to be vertical, y equal to a number is always horizontal. So we see y equal to negative 2. So we'll find negative 2 on the y-axis and then draw that horizontal line. If you want to, you can do a little XY chart if you forget which is which. Y is negative 2 every time. Pick a couple values for x, and you can see 0, negative 2, and 1, negative 2. And then you'll start to see that horizontal line form it. Slope, 1 over 1, y-intercept's negative 3, so plot a point at negative 3, go up 1 to the right 1. And so we have that line graphed. Alright, so our solution is 1, negative 2. Alright, this one, slope is 2 over 1, y-intercept's 2, so put a point at 2, go up 2 to the right 1. You can also go down 2 to the left 1. We'll connect those to form our line. Next one, slope is 2 over 1, y-intercept's negative 4. So plot a point at negative 4, go up 2 to the right 1. You may have noticed that our slope is the same. If our slope's the same and we have different y-intercepts, then they're going to be parallel lines. Parallel lines always have no solution, or you can write empty set. Next one, slope is negative 5 over 1, y-intercept's 3, plot a point at 3, go down 5 to the right 1, and then we'll connect those. Now for this one, we don't have it in slope intercept, but it's pretty easy to get rid of the x term, move it over, so we got y equals negative 5x plus 3. Those are not like terms, you can't combine them. So now our slope is negative 5 over 1, y-intercept's 3, so plot a point at 3, go down down 5 to the right 1, and hopefully you see that these are coinciding lines. They're right on top of each other. So we have infinitely many solutions, or you can write IMS for short. We can't count all the solutions. All the points on one line are on the other. Hope you've enjoyed this video. You can check out more on my website, swayze.weebly.com. Feel free to subscribe.